The graph shows y is equal to f of x on the same grid. Draw the graph of y is equal to 3 minus 2 f of a half x plus 1. So we've got this sort of strange function here. Okay, and what we're going to do is use moving the points. We're going to transform the points in order to draw this graph, but we're going to do it stage by stage. So if we got y is equal to 3 minus 2f of a half x plus 1, it's probably better to write it as y is equal to minus 2f of a half x plus 1 plus 3. So start with f of a half x plus 1. Now you have to do these in the right order. So it's a translation, first of all, minus 1, 0. So that point will go there. This point will go here. This point will go here. This point will go here. And this point will go here. And this point will go here. If we join those up in the same fashion, and this is y of f of x plus 1. Now for the half x, that is a stretch parallel to the x-axis, scale factor 2. So this point is 5 away, so it will go to here. This point is, this point is 4 away, so it will go to minus 8. This point is just 2 away, so it will go to minus 4. Okay, on the other side, this is 2 away, so this will go to here. This point is 4 away, so it will go to here. And this point here is 5 away, so it will go here. And we'll join those up like that, and we'll call that one y is equal to f of a half x plus 1. Okay, moving on to a different graph. So now we're going to consider the minus 2 in front. Okay, so this is how far we've got so far. Right, so the minus 2. The minus sign will be a reflection in the x-axis. So what we'll do, we'll reflect that point down to here. This point will go down to here. This point will go down to here. This point will go down to here. So remember, we're actually reflecting the purple point. So this point here will go down 3 to here. This point here is 2, so it will go down to here. And this point here is 4, so it will go down to here. And then if we join those up, we get that. So that is the reflection, but we've got a 2 in front as well. So that means we then have to stretch it parallel to the y-axis, okay, but going downwards because it was minus 2. So this point here, because it's 1 apart, will go down 2. This point is 3, so it'll go down to minus 6. 2 minus 2, so it'll go down to minus 4. Minus 3, so it'll go down to minus 6. Minus 4, so it'll go down to minus 2, it'll go down to minus 4, and then minus 4 will go down to minus 8, and we get that one. Now you could actually go from that one down to that one in one go if you wanted to. Right, so far so good. Right, so the final step, let's just draw up all these graphs so it should appear. Don't forget we've got down to this group, grey one. Right, so the final step is to now add 3. Remember that the actual function we're doing with that one, but we just rewrote it. So we need to add 3 to each coordinate. So this is going to be a translation 0, 3. So each y-coordinate will go up by 3. So the first point will be that point there, the same as the purple one, so I'll turn it red. This one will be the same as this brown one here, so we'll turn that one red. This one will go to here. This one will go to here. This one will go to here. And this one will go to here. And then if we join that up, that's our final graph. Y is equal to 3 minus 2f of a half x plus 1. So those are all the intermediate steps. And this is the final graph. So this was our original function. And this is the graph of f of 3, y is equal to 3 minus 2f of a half x plus 1. Okay, so this has been a video to show you how to draw a composition of functions given the graph of y is equal to f of x, even though we don't know the equation of the graph. I hope you've understood, and I thank you very much for watching. The applet for the grid I will put into the notes of the video so that you could print it out if you wanted to and use it for yourselves and have a go for yourselves. I hope you've understood. Thank you very much.